end up with three problems, and I've worked them out in advance because I want you to pay attention to the concepts even more than just the actual calculations, because I hope by now, and if it's not true you can stop the video and practice this, I hope by now that you've gotten pretty good at the mechanics of all this and that you can do the combination calculations and that you understand the basic principles that apply. So here I want you to try to see the big picture, and I think I'll just jump right into a problem. This problem says, what is the probability of winning a lottery in which you must choose three numbers from the numbers 1 through 10? And just as a note, I think the best way to think of this to get the idea what they're really asking is that you're sort of assuming that they're taking those numbers and putting them on a piece of paper or putting them on some balls that you draw out of a hat or draw out of an urn. But anyway, there's one number, there's not duplicate numbers. In other words, you can think of it as being a hat full of these numbers, the number 1, the number 2, the number 3, number 4, 5, 6, 7, 8, 9, and 10, and there's just one of each. And we're going to draw three numbers out of the hat, and if those three numbers match the three numbers that a person has, that person would win. So that's the way you're thinking about this. In order to solve the problem, you almost always, at least here, go back to the basic probability principle. The probability that you actually win such a lottery is the number of ways that you could possibly win divided by the number of ways that you could draw out any three. Now, just any three numbers aren't winners. As a matter of fact, there's only one winning combination. So the numerator of the answer, I guess I should be showing that better while I'm talking. The probability of winning is the number of ways you can win divided by the number of ways you can get out any three numbers. And there's only one way that you can win. If you draw out the right three numbers, you win. So there's really only one way to win. But there are lots of ways that you could draw out three numbers. The order doesn't matter, so it's a combination. You're choosing three out of any of the 10, and that combination, again, you know how to calculate that by now, comes out to be 120. So the probability of actually winning this lottery, there's one winning combination out of 120 possibilities. If you happen to want to change that to a decimal, you can. It's about 0.0083 to the nearest 4 decimal places. But I want you to pay attention to the big picture. You've got a lottery, you're thinking of these numbers as being written on a piece of paper, say, and put in a hat and drawn out. And the probability of winning that would be 1 out of 120. Okay, how about another example? This time, we put three names on a ballot in a randomly selected order, and I want to know what the probability is that they come out not in alphabetical order. Certainly more than one way to do this problem, but it seems to me the easiest thing to do here, and again I'm talking about the big picture and thinking it through before you jump into something. The best thing to do is figure out what the probability is of it actually being in alphabetical order. And then the probability that it's not in alphabetical order is 1 minus that. So the probability that it's not in alphabetical order is 1 minus the probability that it is. And I think that you're going to find that's the easiest way to think about this. Well, then what is the probability they're in alphabetical order? Thinking this through, it's going to go back to the multiplication principle. Using the multiplication principle, there are three ways you could choose the first name. Remember, there are three names. You could choose any of the three to put first on the list. And then you could put any of the two in the second, and actually, I wrote this hurriedly, there's one way to choose the third name. I didn't really put that in there, and I guess you could argue that you don't really need to, because 1 times anything doesn't change anything. But there are three names. You could pick any of the three names to go first on the ballot. Once that name is chosen, you can't use it again, so there are two ways to put the second name on the ballot, and once those two names are chosen, there's only one way to choose the third name. That's a total of 6 ways that the names can be arranged on the ballot. Now, out of those 6 ways, only one of those is in alphabetical order, which means the probability that the names do come out in alphabetical order is 1 out of 6. There's only one way that's alphabetical out of the 6 ways possible. But remember, we were not looking for the probability that they were in alphabetical order. We were looking for the probability they were not in alphabetical order. So the probability they're not in alphabetical order, as we said earlier, is 1 minus the probability that they are in alphabetical order. And since we just found out that the probability that they are in alphabetical order is 1/6, the probability that they're not in alphabetical order will be 5/6. Again, think that through and make sure you understand the big picture, because once you're good at doing the calculations and doing all those things, you still have to look at a problem and figure out what type it is and how you're going to approach it. And that's what I'm trying to get at with these problems.